when you learn chemistry, the first thing that we see in a science class is the periodic table. When you look at the periodic table, it gives us a lot of information about elements, about the basic composition of matter. So here you could see, let's see if I can make it bigger. There we go. So this is one of my favorite periodic table. It's online, and I'm going to put a link here in the comments below. And the reason for that is that it allows you to change the language. So here I have English. You can change it. So here you don't see it on the screen, but you can change it in French. You can change it in Mandarin, Arabic, Dutch, and then Korean. There's so many different options. It looks like there's about 30 different languages. So this is something that is amazing. Second, there's also different colors, and that allows us to understand and better understand the periodic table. And that's the work for this week. So let's see if I can look at see if I can put the mic a bit closer. There we go. Let's see if we can look at the periodic table and what it shows us. So first of all, if you look at the periodic table, there's a few things we notice. First of all, it is organized in a big rectangle. And this one is in color. So there's different variety of elements that are going, different colors as you are going through the periodic table from left to right. The next thing here, as you click on this element right here, we have information that is useful. So today we're going to focus on a few pieces of information, which will be this upper number here, which is the atomic number. We have here Li, which is the chemical symbol. On here we have the chemical names, and here we have the atomic mass. So if you go for each of the elements on the periodic table, you have always the same information. Now in the upper right corner, we have a few numbers here, nothing to worry about. We are introducing the periodic table, so that is not what we're going to talk about today. So let's see. So when you look at this overall table here, there's a few things to look into. So first of all, let's look at let's look at the atomic number. So here I have hydrogen, and if you look here, I have a 1 in the upper left corner. If I do helium, I have number 2. And if I go to lithium, 3, barium, 4, bore, 5. And as you can see, every time I go to the next element, this atomic number here is increasing. So we could say that the atomic number is the identity of an element within what we know of matter and chemistry, and also to put its place in the periodic table. Now, what's interesting with the atomic number right here is that it's also giving us the number of protons, a positive subparticle in the nucleus. The protons give the identity to a specific atom, which is part of the element we have here. So that's the first thing. So we have here, and if you look at the numbers going from left to right, so here we have 1 and 2. Here we have on the second row 3, 4, going, as I mentioned, all the way to 10. Then on the third row, so as I go from left to right, what's interesting is that we notice that the atomic numbers are increasing by 1. And then if you go up from the top here, going down, I have the atomic number of 1, 3, 11, 19. So the atomic numbers are also increasing, going downward in the periodic table. So that's one piece of information we can say. The next one we can say, let's see, is about the atomic mass. So if I take hydrogen, which is the first one, I have 1.008. I go to helium, I have 4.0026, lithium 6.94. So as you can see, we have a number that changes for every single element. Now on top of that, if you go from left to right, let's see, we'll go from boron, I have 10.8, 12.01, 14, 15.99, fluorine 19, 18.99. As you can see, going from left to right, the atomic mass is also increasing. And if you go down one column, so I have here, let's take lithium 6.4, I go to sodium 22.9, and then 39.09. So as I go down a column, we also increase the atomic mass. So here's something to look into, and including if you look at the atomic mass of 6.94 for lithium and the atomic number, you will notice that the atomic mass is always higher than the number that represents the atomic number. So lithium here, I have 6.94 and 3. If I take iron, 55.8 and 26. If I take mercury, I have 200.59 and the atomic number is 80. So that's something that we know is always happening. Perfect. So we talked about this trend, the next trend. Let's look at some other trends. So if you look on the first row, we have what we call two elements, which are hydrogen and helium. If you go on the second row, we have 8 elements, starting with, let's see, lithium, beryllium, and then we have bore, carbon, nitrogen. We have, okay, let's start again. So we have lithium, beryllium, bore. I'm trying to look at the screen and look at you at the same time. We have carbon, nitrogen, we have oxygen, fluorine, and neon. So that means that on the second row, we have 8 elements. Now, when we think of rows on a periodic table, we can also say we call them periods. So here, we look at the number here, the first period is the first row. The second period is the second row, and the third period is the third row. So period is a good one to know. Now, if you are going vertically right now, we have group numbers. So here we have group 1, group 2. So group 2 here are basically, the second column. If you go to group 18, I don't have to click on them. Group 18 here, which is the far right column, or we have here, let's see what else. The alkali metal, we have columns. So columns have specific properties also. And what's interesting, we have 18 columns in the periodic table. Each of the columns, we can call them groups. So this is group 18. This is here group 2. Sometimes in family, we call them family of elements. Every so often in this video, I may call them groups or family of elements. Both will come out, but the best way to say it is the first or second group. So here's vocabulary. That's good. That's good. And perfect. Let's look at some names now. As you can see, there are different colors here. So let's see what they are. So first of all, we have the first column, and we call them alkali metals. So the alkali metals comprises lithium, sodium, potassium, rubidium, cesium, and francium. So they are all in the same group. And what's interesting here is that this group has similar properties when these metals are close to either oxygen and water. Another group that has its own name is they're called alkali earth metals. The alkali earth metals, there you go. They are the second column in the periodic table. And the reason why they are all part of the same column is that they have similar properties given similar environment. Now, the next group that is interesting will be the transition metal. So transition metals are interesting. So in that group, usually I include transition metal, post-transition metal, and ever so often, there's also poor metals depending on who we talk about. But transition metal and post-transition metals are these two right here. So what's interesting, they are two groups of metals. They have specific properties and they sit right in the middle of the periodic table. The next group of elements are what we call the metalloids. So the metalloids, what's interesting is that they are sitting between the transition metals and the non-metals. Now, what's interesting with the metalloids, so as you can see, they're sitting between metals and non-metals, is that metalloids will react to different materials depending on the environment. So that means that if we have, for example, metalloids in contact with non-metals, metalloids can react or act sometimes in similar way to what metals are. Now, if it happens that metalloids are in contact with metals. Here, for example, are the alkali metals. What happens is that the metalloids at that time may react in a similar way or similar fashion to what a metal will look like. So that's what makes the metalloids something interesting. Now we have at the far right, we have what we call the noble gases. Sometimes, so these are interesting because they tend to react very little to their environment. Other ways we can say it, we can call it, so noble gases are good. I've heard about inert gases. So inert gases is another way. And I think that is the other way I know in English. Now here in the reactive nonmetals, what's interesting here is that if you look at the second last column, so this second last column is this one with fluorine. So fluorine, chlorine, bromine, and iodine. So here on this second last one, they are reacting similarly depending on the environment. So what's interesting with the second last group, we also give them a specific name, and they're called halogens. So halogens are a group of elements that are located on the second last column right here, the second last group. So just a quick review, we have the alkali metals that we learned in grade 9, the alkali earth metals. We also have the transition metals, and I include the post-transition metal into the grouping of transition metal in grade 9. We have the metalloids, which are located between the metals, and here the non-metals, and we have the noble gases at the end. So this is what is the organization of the periodic table. That's a great way to visualize what it is. We also included vocabulary. We also talked about the periods and the groups and the vocabulary. So here it's great because we are ready for the next information, the next video about information that we can gather and collect from the periodic table.